thank you very much. I indeed did many presentations for Wi-Fi Design Day, and actually somebody just asked me, are you going to present an update on innovation of locationing? I think last year I did something on how we can use maybe 6 gigahertz spectrum, and I think David was talking about it, maybe to serve it as more slicing it and try to think about it differently from a design perspective. But when Matt asked me to come up with a topic, actually, to be honest, I don't know what was going on with myself, but I was a little bit sick and tired of some of the stations that we saw with power save mode. So I said to Matt, let's do a presentation on power save mode. And boy, I regret that decision when I started that. But okay, I went to it, and I hope you find it valuable, and I hope it's not too boring for you. And the other thing is, I have some news to share, and sometimes it's not good if you drink a lot of beers in the evening, and that was happening. I'm not sure, I think I saw him somewhere, but last year somebody was presenting his journey of his own company, and he was talking about the great integration between Cisco Meraki and Ekahau. And I think I saw him in the room, and I saw him later at the bar also. And he mentioned to me, and by the way, it was not the Juniper acquisition, buying Juniper, that was not what we drink, but this was an integration. Now we have our integration in Aruba Central. So here, as you see Aruba Central, when you go to, now the floor plan is normally empty, right? And you need to add these things yourself. So if you now go to Ekahau Insights, and there you can click, you can export, you need to add a token, you need to add, say which cluster, and then you can continue. Then automatically, we now also have that integration ready. You can see a complete new site being configured, APs being part of it, and also now the floor plan is in. This is actually the start, right? We are talking about doing things more, but we need to move a little bit to new APIs to get going. So this is the start. That was the thing that some of the news to share. And about Juniper, I can't say anything about it. We first need to close the deal. There's a lot of tick boxes we need to do. So probably about the end of the year is a little bit more meaningful, and we can do the closure and the organization and everything. But in general, it becomes a 10 billion networking business unit for HPE. So that's a massive business unit, and I think a great competitor to make sure we can all innovate better. So maybe next year I can present a little bit about what we're going to do. So if you start diving into power save mode, it's a very special world. There's many different actually really power safe features, but there's also a lot of features that are around it. So this is roughly a summary, but I think I can come up with much more functionality that maybe do something on power save mode. But since I only have 20 minutes, and I think this will become my personal record in the amount of slides I need to present in this, is I'm going to focus on a few. Is legacy power save mode, let's say null, data power save mode, WMM power save mode, then only on UAPSD, and spatial multiplexing power save mode. So that's the 4 I'm trying to focus on. But first I want to set a basic, because many of the things are more like an evolution of the other, or added some functionality or remove some stuff in order to optimize it. So if I really need to summarize it, and I had to do this presentation in a few seconds, it would be this, right? Either you're awake, you're either transmit or receiving, or you are sleeping as a station and trying to, consume some battery life, some battery time. But if you're really looking at, there is a couple of states you can be in. So if you're looking at from a power consumption state, you can either transmit data, or you can be in the second state is either receiving the data, or you can be in a listening mode, where you're looking for the 5 preambles to react on something, or you can completely be in a sleep state. Then from a PS, from a power save state, there's probably 2. There's in PS, more or less as a station, you say to the AP, from now on, you need to buffer my packets. So the station X, and then you buffer the packets. It doesn't mean that the station maybe is in sleep. You don't know, but at least from an AP perspective, you need to buffer the packets. The other one is you get out of PS, so you say to the AP, give me all the packets you buffered for me, and get all these frames in. Then, if you're looking at it, it works roughly like this. If we start with legacy power save mode, so you have a power, you say, the client says, I'm going in power, then the AP acts, and then at that moment in time, the AP starts to buffer these frames, and the client says, I'm going out of power, and then you more or less send these traffic. Before you diving into this, you need to understand how the AP is keeping track of what state a device is in. And the association idea is key in this one. By the way, you immediately see my amazing naming. I do this I don't have other vendors' APIs, right? So I do everything on HP Aruba, so probably every vendor has his own CLI or whatever command to figure this out. But you can see my naming convention is 5i. My last name is Ingen, and we are with 5. I have 3 sons. Then the other one is I name my AP work to make sure that everybody in Aruba believes that I really work. And they think, wow, that's impressive if they are on this AP. And then I let my sons connect with the 3 PlayStations to my AP. So at least I have some data. But if you do this command, you can see the show AP association, and then you can see the client information. You can see some of the capabilities, and you can also see the AID, the association ID here. So then, if you go to debug client, you can get more information if you want, right? You can see the mode it in, if it is TVT or UAPSD, you can see all the information that you want to do from a troubleshooting perspective. And then if you want to go further, you can even see, if you don't want to see it like 0x, you can see here the association identifier. So let's say you don't have access, and by the way, it's a pretty bit embarrassing if you're after Roel with his all perfectly looking power, his perfectly looking packet captures and following all the tips and tricks, and then you got me. I'm a little bit more chaotic with everything. But if you don't have access to the CLI, or you want to do some troubleshooting, or you like Keith flying in a personal jet and you need to capture a packet, then you can see here in the association response packet, you can see the association ID also. So this is important. I get back to it why it is so important. So how does a station notify the AP to buffer packets? It does this with this frame, right? Your no function, it goes to sleep, and you can see here the P bit is set, and it says, hey, I'm going into more or less sleep mode. If it sleeps or not, you don't know, but at least the AP knows I need to buffer. After that, the AP will act it, and then it will start to buffer the packets. So how does a station then become active? The same thing roughly. You can see here, there is a beacon, and in that beacon you can see on one frame, let me do this cool thing as everybody else is doing here, and it's not working. Oh man, I got sick of this. So here you can see 0x01. That's the association identifier to say, hey, I have packets for you in my beacon. Then the station will say, hey, that's nice, I need to wake up. And so here you can see the packet, and then they say, okay, I need to wake up. You got an ACK, and you got the information. So how does an AP know that it doesn't need to buffer for like ages, like hours of packets, right? So and this is also, I think you mentioned that we're not always agreeing in this industry. This is another special thing that everybody can make up their own timers roughly. Here, you can see a listen interval. And this is coming from the association request from the client. And you can see it here, that's a hex value. In this particular case, it means 20 decimal, meaning what the AP can make the assumption that once every 20 beacons, he will have a look if there's traffic buffered for him. So here is one from a Windows laptop, and Windows sometimes even is different if you take it in a docking station, out of docking station, on power, not on power. So you can see here, this one is more or less every beacon it will listen. So now, how will you get this unicast delivery of the packet? So the first one is, you can see in the legacy power save mode, there is ready association identifier in the TIM field. Then the client sends a PS poll packet. Then the AP sends an ACK, sends the data, and if there is more data available, it sets the more data bit to 1. The client acts, PS poll packet, other data, ACK. Yeah, so you can see the dancing of the ACKs and everything going around. Not massively efficient, but that's how it worked at that moment in time. Here you can see an example. traffic buffered at the AP. You can see PS pool ready to receive packets. You can see the ACK coming. Then you get a whole dancing of RTS, CTS, maybe some sounding, and then you get your packets. In this case, it was a ping packet of 500 baud, which was over the air 582. That's how this was working. So the TIM element, I explained to you how that's working with the association identifier. But how does the DTIM element, and DTIM is important for broadcast and multicast traffic. So TIM is being used for, let's say, the unicast traffic with the association identifier. Then the DTIM field inside the TIM is used for multicast and broadcast traffic. So here you go. A DTIM period of 1, 0 is reserved, means that more or less every DTIM or every TIM is a DTIM. So this is in HP Aruba the default. I think most vendors probably have that as default. So you can see the D count, the DTIM count is 0 here. So that means that this current TIM is the DTIM. So if you want to change it, for those that like the UI, here you can change it to 3 beacons. I say change it from 1 to 3, and then you can see here how this goes. The first one coming in, you can see the DTIM period is 3, right? Every 3 beacons, I changed that. You can see the DTIM count is 2 because it counts itself with it. So then you get the other one, 1, and then bang, we have the DTIM of 0, then is that delivered. So how that will go, so this is the DTIM count 0, so meaning this TIM is also the DTIM. You can see in the bitmap control field that the multicast is true, so there's multicast packet. After the DTIM is 0, immediately the broadcast is being sent. So there's no messaging, it's just sent out there. Okay. Yes, I know this is very, very ancient, and I think you have been learning this probably years ago. But believe me, many devices inside all of your environments or your customer environments still use agent devices that still use PS-POL. Believe me or not, I will not name the vendor, but we recently had a VHT laptop with a very modern chipset doing PS-POL as its power saving mode. So it is, we are not always agreeing in this world. So it depends, so to say. Can this be no more optimized? More popular method, and this is a little bit the de facto these days, but I will get back to a few others, but you see it a lot, is where you do the following. You still use the beacon, you still use the association identifier, then you send the null data frame with the power management bit to 1 ACK, and then you can send the data immediately. If there's more data, 1 ACK. So you can see this is already optimized. You're combining a few things in one, so to say. Then the null what? The null data frame is a control frame. It can only send by stations. And for those that are really want to know, here you can see what is coming out of the standards, how you can see it, and you get more information. So this is a Google Pixel, according to my MacBook ping. What you can see here is the TIM field, association identifiers in there. Then you got all the packets being sent, and immediately can go to receive and sleep. So you can see this is optimized. A lot of the modern voice over IP phones in the market these days also using this, as many different devices using this method now. Then you go to automatic power save delivery, APSD, which is pretty important actually because it is also was part of the E amendment, which became part of the standard in 2020, where everything got rolled up into that particular standard. There's a couple of modes, is static, or scheduled and unscheduled APSD. For the Wi-Fi Alliance to be power save compliant, you need only the UAPSD and not the SAPSD. So I also only focused for this one on the UAPSD. So if you have an Intel client, you want to test around, play around with it, you have a little bit newer, you can see here that you can enable it. It's by default, it's spatial multiplexing, which I will show after this one, but you can enable it. How does that work? So you're using the QoS data frames, right? So there, send QoS, trigger ACs, ACK, and then if there's more data, EOSP is 0. It's also nice that it's either 1 or 0. that we are in line with everything, we do the same thing. But then it's UCK, and then if there's no data anymore, and it's UCK, and you can go back to sleep. So let's have a little bit of a look. The advertisements here is either in the beacon frame, you can see here, there's nothing there, but down you look in the WMM element, and in the WMM element you can see how you enable it and for what buffers you have been enabled. You can tweak with this, but most of it is almost all buffers are enabled for it if you enable it. You can also see it in a probe response packet. So more or less the same thing, so not too excited, but you can see it in 2 packets at least, then you have that information. Then association request, you can see it. This is a Windows AX210 chipset. You can see here, it is enabled, all the frames. This is a Cisco IP phone, so then you believe that at least I'm telling a little bit of the truth that these vendors are using this, in this particular case. How can you verify the information? Again, look at the association ID. Then important, you can see, at least, I don't know how this works in other vendors, but in us, you can see it on the CLI, you can see that it is triggered for all the different buffers in the client table, right? You see UAPSD, you can see 11111. Then the maximum served period length, which is important if you are in older environments. A newer one, not so much, but here you can see the max SP length is bit 5 and 6. It's 0, 0. What it means, it will deliver all the packets in one go. When you have older Cisco IP phones, in particular the wireless phones, then what you see there is that the very old ones were not able to have a receive buffer capacity to receive everything in one thing. So they played around with this. That's long gone now because they are most of the time not using this method anymore, but at least if you need to troubleshoot it, if you want to understand it, you have some information that's sometimes where you see that's different because they don't have the buffer capacity to receive all the packets being buffered. So you can play around with it. So let's have a closer look. This one, Cisco, so triggered on, all AC is triggered, so immediately you get a trigger packet where then in between you get all the packets being delivered to you, and then automatically more packets is being buffered, as I said, then out of a sudden it will reply to the ping and immediately sleep. So it's pretty efficient methodology. One of the things that you probably see if you're looking in Windows devices the most, you will see spatial multiplexing power save. That's a little bit what they also call the MIMO power save. The default setting, at least on the Intel chipset, is auto. You can set it to static, which you see sometimes on the older Intel chipset, and the newer ones can also use set to dynamic. It's 11N and further, right? So then in this particular case, what will happen in static mode, more or less, if you have a 2x2 or 4x4, you close the other RF chains and you leave one open. So actually your device becomes a single spatial stream device. That's what it does, to save power on the other ones. Then in dynamic, the client can listen on one, and more or less the AP can trigger the client also to start waking up. For example, by sending an RTS, CTS, and then the rest of the RF chains can wake up, and you can send. So I have an example. Here's static mode. You can see static mode. I don't have so much things to show about this because what I've seen, static mode has the possibility to enable the other change, but I don't see actually, I didn't saw so many clients that really do it. Actually, static is static and you just turn off the rest. That's what I've seen in particular with Intel, which is using this heavily. So you can see it here also again on the CLI, you can see what power save is being used and if it is static mode or dynamic mode. In dynamic mode, it becomes a little bit more interesting. You can see here, dynamic mode is enabled. You can see it also on the CLI. And if you're then looking at the packets, you can see here is an instant of an echo, right? So this is a ping echo every 5 seconds. So to get a little bit of a clean testing environment. So you can see here, like 5 seconds later, it will wake up. Then you got again, you can see that the AP sends this RTS, CTS. So more or less saying to the client, you need to wake up your other chains. This is a 2x2 client. So you can see in the spatial streams information, man, I got really official here, right? It's 1111 and bang, there it becomes 2. So now the AP delivers with 2 spatial streams to this client at ping. So that's how spatial multiplexing working, auto or dynamic mode you can choose and can play around with it. Intel wireless adapters, you can select it here. Default, auto, as in most implementations I've seen, but you can play around with this if you want to do your own testing environment. I think for Linux, they have a special page where you can configure these devices. Also, I think they have a very special page there. So now, you see, 20 minutes. 40 slides in 20 minutes. The only thing, before we end up, I've been here many times, and I want to thank Open Reality, and I want to thank MetaMac and the whole Echo team for organizing it. And I will shut up and make sure I get time for the other vendors. So thank you very much.